just check that we're streaming. Yep, looks like we're streaming. Okay. So again, hi everybody. And today we're gonna, as always, stream solution to a Python program. Let's see if the camera catches me correctly this time. Yep. Okay. Yeah. That looks good. Okay. Cool. So we're basically going to write something that does reverse Polish notation. Reverse Polish notation means the elements come first and then the operation. And this is pretty straightforward because the nice thing about reverse Polish notation is all you need is a stack. But as always, first we'll kind of put the inputs and okay, that's I'm gonna copy and paste, and I'll just type from scratch because it's long. Okay, so now we have a little bit of test data, and we know the first one is supposed to return 8. Sorry, and the next one is supposed to return 5. Okay, so let's write evaluate RPN. We'll get an expression. Okay, and now basically we just loop through the expression. Let's name it something like in expr. Now there's a bunch of ways to do it, but let's first only implement addition, right? So if L equal plus, and here's a trick, right? We can assume the expression is always valid. So if we have a stack, then the expression being always valid means that a plus cannot come on its own unless there's been at least 2 operands behind it, right? So we can literally do stack.append l.pop plus l stack.append stack.pop plus stack.pop. And let's do continue. And otherwise, let's do stack append L. And this only supports plus, so it will only return the right value for the first one. And we forgot, of course, to do that. Return stack.pop. Okay, and let's, if you're kind of wondering what's going to happen, let's kind of print the stack at each step. So let's kind of understand what's going on here. So the first element is appended because it's not a plus. Then the second element is appended. This does continue. So let's before the continue also print the stack. Okay, and then the 2 top elements are popped. So of course we can only do pluses. So let's do something still more complicated with plus. Let's want to add 1 plus 2 plus 3. Right. So first we have to add 1 and 2, and then we want to add it to 3. So this is how you'd spell 1 plus 2 plus 3. And you see that we push 1. Maybe those were, like, let's do 4 plus 5 plus 3 to make it easier. So 4 plus 5, when the 5 is pushed, then 9, then the 3 is pushed, and then 12, and that's it. Okay, so this works. And of course, we can easily do multiplications. Right, let's remove the print because now we understand what's going on. Elif, L equal equal. And instead of continue, we'll do else stack dot push append L. And now we can keep the printing of the stack here, and we don't need continues. So this will be clear. And the reason I'm not doing subtraction division for now is you will see in a minute. And we're actually going to simplify the code in a minute. But first let's do that. And let's do 4 plus 5 times 3. That's going to be 9 times 3, which is 27. Wonderful. Okay. Now you'll notice that when we subtract, suddenly we can't just pop both elements, right? Because we have to make sure that. So let's look carefully what it means to do subtraction, right? When we subtract, you'll see we first take the first one, meaning the one that's deeper on the stack, minus the second one, right? So let's kind of do 5 minus 4. Okay. Then we'll call it the from and the to. And that's actually in the first. Okay. So the order matters here, right? We first pop the first element, then we pop the second element, and then we do a stack dot append of from minus 2. From is with an underscore because from is a keyword. And that's not going to matter because we'll simplify the code in a little bit. But I just want to here. So this is 1, right? And minus is not commutative, right? It's anti-commutative, right? So if we do 4 minus 5, should expect minus 1. I'm really glad I have the print of the stack here. We'll keep it and eventually we'll get rid of it, but this is really useful to see what's going on. And now division is the same, and we'll keep the names even though they kind of are less good for division, but anyway, like I said, we'll simplify the code. We have a bunch of simplifications to make, so. And now we can actually evaluate the second one, and we should get the right result now. Whoop. Stack.pop. Because we didn't do actually division, so it okay. Good. And it returned 2. And it should have returned 5. So let's figure out what went wrong here. So 15 divided so 15 7 1 1, and then we add. Okay, so that's good. And then we subtract. So 15 divided by 5. So we appended 3 and we should have multiplied. So yes, here. Okay, yeah, that was a silly mistake. And now we got the desired result, right? So having a nice thing to debug it was really useful. Okay, so this code is correct now, right? It does kind of convert it into a float. What division should do is not really obvious if it's not complete. Let's do integer division just to kind of and in this space I would ask the interviewer, okay, so what should I do if I get, say, 5 divided by 2? What would you like the result to be? And they can say we want integral division, or we want it to convert it to a float, or whatever, and then I would do whatever the interviewer say. Let's say the interviewer said to do integer division. And okay, so now the code is correct, right? And now, as always, the annoying interviewer comes in and say, it looks like you have a little bit of copy paste here. How would you remove a lot of this copy paste? Because if you remember when we wrote the code, we literally did a lot of copy paste. So here's how I would do it, and I would use the Python operator module. So import operator. And now, of course, I don't remember. Okay, so operator is a nice module, and among other things, it has here add and subtract, right? If you look for mul, matmul is something different, right? Mul, here it's a button b, and if you look for sub, then you'll see sub, and let's see what is integer division. Floor div, I think that's what it's called. Yep, okay, awesome. So now we can define like a little dictionary. We'll call it, say, operations. Operations equals. Now we just have to define the semantics, right? This is operator.add is operator.mul. This is operator.sub, and this is operator.floorDiv. And if you notice, we literally this checks that all these things exist. So now we can do if L in operations, then we do operand 1 stack dot pop, and if you notice, this is in the wrong order. That's actually the right thing to do. We first have to pop the second operand, and then to pop the first operand, right? If you remember the example of here, say this is 9 minus 4, right? So first we pop 4, and that's the second operand. And then we do operations of L operand 1, operand 2. Now we can remove all these copy paste. So that's why I said we were going to simplify, and I didn't care about the names, because anyway they were going to be generic. Floop. That needs to be stack dot append the result, otherwise we just take the result and throw it away. Here we go. Wonderful. So as you can see, this code is a lot simpler. So I'm gonna be still assuming that I'm facing an annoying interviewer, right? So the annoying interviewer now comes and say, okay, so talk to me about the performance. I can talk to you about the performance. Stack is a list. Appending to a list is actually pretty fast. What's pretty fast? Says the annoying interviewer. Well, so Python is pretty good at that. So it appends stuff, but it actually gives it a bit of extra space. So you don't actually have a quadratic algorithm. Oh, but can you make sure it's O of 1? Annoying interviewer is annoying. Well, luckily Python has got our back, and we'll open the collection module. And we'll check the help for collections DQ. It has a max len, which is actually kind of nice when we want to use it right here. And if you look at the operations, it has an append, and it has a pop, and it's optimized for data access and is near its point, and basically that means that it's O of 1 to append. Also we can do collections DQ, and the beauty of Python is that this is the only thing that needs to change. So as you can see, the printout is different, and actually now the printout is, can be very slow, right? So we should disable it when we actually go into production. We should disable it before we go into production, or maybe in real life I would do like some logging with debug or something like that. But for readability right now, I'll just leave it here because it shows what's going on. You know what's going on is the same thing. So yep, just works, right? Let's remove the print stack. And honestly, at this point, the interviewer is kind of done. I don't think, even in my worst interviewer persona, I can find something to improve in this code. It's basically as efficient as it can be. This line is kind of long. Maybe we can break this up. If I want it to be a bit more readable, I would maybe do this. In the future, maybe this can be like a good logging point if we want. And result, again, it shouldn't change the operation. If the interviewer wants like non-floor division, we can do true div here. In this case, it will be 5-0, but if we change this to 2, you'll see that there's a bigger difference. Anyway, is it true div? What if we just put div? There's no div. Okay, good. So this only, okay, let's return it to floor div because that's our assumption. That's what people want. Wonderful. Here, let's change this into 10 and see a big difference. Oh, No, this is not what we need to change. What we need to change is the 3. Okay. Yeah, so if we change this to 4, or 10, it's intuitive. What if it's floor div? It's going to be very different. Okay, so I'm not really sure. Oh, no, that's not again not what we wanted. Okay, so what was this before 3? The division is here 7. Okay, so here if we make this 7 a bit bigger, 8. Here we go, 2. And if we have true div, 3.5. Right? So that's a bigger difference, right? If we had that, let's kind of change this back to 7, right? So like I said, like this is not a really equivalent in terms of the float, whether it's it really does change the operation. But like I said, 577. Yep. Okay. So we went back to the original. So like I said, like this is something that you would want to ask the interviewer. And sometimes the interviewer is do whatever you want. In that case, I would do floor div because it's kind of easier to explain what's going on, because it's integers and it's kind of annoying and whatever. But usually the interviewer will give you specific guidance. Again, you can assume the operator is always valid. So if you evaluate, say, 1, 0 div, you get a 0 division error, right? Because it's invalid to divide 1 by 0. Sometimes that would be a good question to ask your interviewer. So when you say always valid, do you mean syntactically valid or do you mean semantically valid? What if there is one divided by 0? What would you want me to do? And if they say it doesn't matter, then it doesn't matter. If they say it does matter, then you do whatever you need. So let's say that they want that if you try to divide by 0, then you return 0 instead of raising an exception. Then you can do something like except 0 division error result equals 0. Okay, it's not a great solution, right? But there is no great solution. The right solution is actually to raise an exception and then to let the user figure out what they did wrong. But it's good to understand the requirements. So this is one thing that you should be explicitly asking. When you're saying the expression is always valid, do you mean merely syntactic validness, which means you don't have to check that there is enough things in the stack? Because the other thing that can happen is, say if you do this, right, right, this will also raise an exception because it tries to pop from an empty queue. By the way, it'll be slightly different if you it'll be a slightly different exception. It will be pop from an empty list, but it's the same issue, right? So this is what I assume you can assume that the operation is always syntactically valid. You don't have to do any checking. It's fine to raise an index error, but I would ask whether you also mean semantically valid, which means no division by 0. And this is one reason why floor div is nice, because otherwise, well, what if it's really, really close to 0? What kind of a underflow and overflow thing you want me to do? With integers, there's never a question. Integer operations are very carefully defined. So this is like all the variants that they can ask you about it. As you saw, first I made sure that I had something that kind of works, and then I started refining it. Well, my first version didn't even work on anything except this one. And then I made something that worked on the bigger one. And only then did I introduce the operations that made it kind of a little bit nicer. But actually, writing nicer code is more time consuming than writing the first draft. So it is good to write the first draft. And then I added collections EQ to make sure that our algorithm is O of 1. It, well, you know, O of 1 each step, of course, O of n in the number of operations. It is O of n in the size of the list, but that is impossible to prevent, right? If we get like something like the Alice in Wonderland question, right? So for those who don't know, remember Alice in Wonderland by heart, like I do. The queen asks her to add a number of ones that is very big. So let's do plus. So let's. So this should give us 10, right? Because we are adding 10. But I think I don't remember exactly how much the queen asks her. So I guess you can argue. But right, so in this case, you have to make sure to put all the ones together because you have no idea what operations you're going to do until you get here, right? So on average, the stack can be as big as half the list, right? So the maximum memory that you might need is anyway over the list, so you can't do really any better than that. Okay, I think that's pretty much all I can talk about this question. I guess let me know if you have more questions about what other interviewers you think could do if they're annoying enough and ask you. Otherwise, goodbye. I enjoyed streaming to you. And this will be available later for offline watching if you did not get to watch it. So if you're watching it offline, please do send me a comment. That's okay too.